Hi, and welcome to 2.7, more work with compound inequalities. So we're going to use some of what we learned last time, and some of it is just practice. Okay, so the first thing we're going to be doing is graphing these on the number lines. And then for these two that are written as two separate statements, we're going to write them as one single statement. So right here, we've got x is less than 1, so 1 is not included, so we've got that, and then it's going to be less than going this way, or we're including 4 in this circumstance, and we are going that way because it's greater than. Okay, this one is also an or, and we've got greater than 7, so 7 is not included, we're showing greater than. And this one is going to be less than -2. -2 also not included, and we're going this way to show all of the ones that are less than -2. Okay, this one we are going to be greater than -3, so -3 is not included, and we're going to be going this way. And then on this one, 5 is, we're less than 5, 5 is not included, so we have this little section right here. And the way we can write that is -3 is less than x is less than 5. And I like writing them in one single inequality because it kind of shows what's going on here. We can see that it's the space in between those. Okay, this one, both of these are included. So we're going less than -9 and greater than 0. And we want to include all the numbers that are in between there. And so that's going to be 0 is less than or equal to x is less than or equal to 9. Okay, going down here, we are rewriting them as two inequalities, and then we're using the and connector and then graphing what they look like. So I'll do the first one and then you can do the second one. So on this one, we've got x is greater than or equal to -4, and x is less than 6, and so -4, and 6 is going to be not included, and we're looking at all of the numbers that are in between there. Okay, pause it and try the second one by yourself. And the second one is going to be x is greater than -5, and x is less than 9, and we're looking between 5 and 9. Both are included, and we've got the space in between there. Okay, down here, now we're going to write the inequality. And so this one, we're looking from -1 on down to -infinity. So it's going to be x is less than -1, open circle, so it's not included, or x is greater than or equal to 5. Okay, pause it and try this one by yourself. Okay, this one's going to be -8 is less than, x is less than 2. All right, moving on. I'm going to do the first one, and then you can try the ones after that. So we are checking to see, so notice our inequalities that we've got right now, our compound inequality. It's a little bit more complicated. It's got more than one step to it. So, but we're still going to do the same thing we did last time, which is substitute the 5 into both of those and see if they're true or not. So on this one, we've got 6 times 5 plus 1 is greater than or equal to 4, and -2 times 5 plus 8 is greater than -12, and we want and on this. So this is 30 plus 1 is greater than or equal to 4, and 31 is greater than or equal to 4. So this part is true. And then this one, we've got -2 times 5 is -10 plus 8 greater than -12. -2 is greater than -12, so this part is true. So yes, 5 is in the solution set to that one. Okay, you try the next ones, -3 and 10, and unpause it when you come back. Okay, and here are the solutions to that. So x equals -3 is no, and because the first one is not true, And then on the second one, no, the first one is true, but the second one is false. Okay, let's move on to solving this compound inequality. So we're going to solve each of them separately. So we've got 6x plus 1 is greater than or equal to 4. I'm going to subtract 1 from both sides. 6x is greater than or equal to 3. Divide both sides by 6, and we have x is greater than or equal to 1/2. So that's the first part of it. And negative 2x plus 8 is greater than negative 12. Subtract 8 from both sides. Negative 2x is greater than negative 20. Now we're going to divide both sides by negative 2, which means that we are going to flip the inequality sign, and negative 20 divided by negative 2 is positive 10. So we have x is greater than or equal to 1/2. So 1/2 is included. On this one, 10 is not included, and we're talking about less than, so this is our intersection that we're looking at right there. Okay, this one, we're doing the same thing, so we're checking this in here. So I'll do the first one for you. We've got 1/2, negative 6 plus 4 is less than 5, or negative 2 times negative 6 minus 4 less than or equal to 14. So on this one, we can try one of them, and if one of them works, we already know it's true, and we don't have to try the other one. So this one is 1/2 times negative 2 less than 5. That is negative 1, and negative 1 is less than 5, so I can go ahead and say yes, because the first one is true, even if we don't know about the second one yet, because only one of them has to be true. Okay, your turn. Go ahead and try the next two and unpause it when you're finished. Okay, so on this one, yes, this is true, and yes, this one is true. These are both true. On this one, false, and then the second one is true with the x equals 8. Okay, so everything is true. Let's see what that looks like when we actually solve it. So we have 1/2 times x plus 4 is less than 5. And we're going to multiply both sides by the reciprocal, which is 2. So we've got x plus 4 is less than 5 times 2 is 10, minus 4 from both sides, and we've got x is less than 6. Or we have negative 2 times the quantity x minus 4 less than or equal to 14. We're going to divide both sides by negative 2, and when we do that, we've got x minus 4, and we have to flip our inequality sign because we divided both sides by a negative. So that's negative 7. And then we're going to add 4 to both sides. And so we have x is greater than or equal to negative 3. So x is less than 6. So here's our less than 6, and that's going this way. And then we've got greater than negative 3, and it's showing here. And so since we have the or, we're looking for everything that is covered by both lines, and that is everything. So our solution set is going to be all real numbers in this case. So that's our answer. Okay, now sometimes we're going to have word problems that we want to represent in an equation. So we've got an amusement park. There's only room for 4,500 people to be in the park at any time. The manager has also shown that you need at least 2,800 people to make a profit. People are entering the park at the rate of 12 people per minute, and there are already 850 people in the park currently. We want to know between how many minutes should the door stay open to let guests in. So it can stay open for a while, and there will be enough people to make a profit but not fill the park yet, and then they have to stop when the park is filled. So our lower limit is 2,800 people, and that's going to be less than you want in the park or equal to. It's okay if we have exactly that many people. You'll make a profit in that case. And then our upper limit over here, and it's okay if there's that many people in there too, is going to be 4,500. And then the actual people that are in the park, 12 people per minute. So we're going to say 12x, where x is the number of minutes that the doors are open, minutes, and then there are already 850 people, so we have to take into account those people as well. So that's our compound inequality that we're looking at. And then we want to solve the compound inequality. So it's easier to separate it, at least I think. So I'm going to rewrite them separately so that I can solve. And so I'm going to subtract 850 from both sides. And so I have 1,950 is less than 12x divided by 12, and I get 162.5 is less than or equal to x. So that's my lower limit of minutes, 162.5 minutes. And then over here, I have 12x plus 850 less than or equal to 4,500. Subtract 850 from both sides. So now I have 12x is less than or equal to 3,650 divided by 12. X is less than or equal to 304. And then on my calculator, it says it's 304.16 repeating. That's the same thing as 1/6. So I'm going to put 1/6. I just like fractions, but you could certainly put that and that would be okay too. And then I'm going to rewrite it as a single statement. So that looks like 162.5 is less than or equal to x, which is less than or equal to 304 and 1/6. And I could put this one as 1/2 too if I wanted to. All right, so that's the end of that. And please do write down any questions or put a star by anything you have questions, and then we can talk about it in class.